Hello and welcome to the third part of our fourth lesson in Unit 5 Sine Functions in our Grade 11 University College math class. This lesson is all about bringing all the transformations together. We learned what D and C do with respect to transformations. We reviewed what A does. So far we've tackled one vertical translation in example 1. We've tackled one horizontal translation or phase shift in example 2. Now we're going to not only do either vertical translations or horizontal translations or put them together, we're also going to introduce different considerations for the A value as well when we're setting the vertical scale. Lots to consider here. Let's jump right into example C. So we have y equals 3 sine x minus 2. So our amplitude, that's going to be our A value. So there it is. That is not a highlighter. There we go. So that's going to be an A value of 3. And our period, as always, nice, keep saying it, we're not doing anything more. We're not doing any horizontal expansions or compression. So our period will be 360 if we're talking about angles of rotation most of the time. Now the phase shift occurs in the brackets. So if we had a sine bracket x plus or minus d, that would be a phase shift. We clearly don't have that here, so phase shift will be none. And our vertical translation is the last one, and that's our C value, and that shows up right here at the end. And the C value, like the K value in a parabola, we take at face value. So that's going to be a vertical translation, 2 units, and because it is a minus 2, we're going to be going down. We're going to save the range, as always, till the end, if I remember it. So let's start with getting our horizontal axis labeled up. Now, as I modeled in our first example, with no phase shift, I just draw in a vertical axis over here as far to the left as I can. And I draw it. Little arrow on top, that's going to be my y values, all the way down to the bottom. Looking good. So that's going to be 0. And with no phase shifts going on, I look all the way to the far side, and I'm going to make that my 360 degrees. Halfway between them, again, this is in the spirit of getting our 5-point system up and running. There's 180, there's 90, and there's 270. So let's label those. I'm just eyeballing those, trying to get them as close as I can. So 90, 180, 270, and then the 360, which we already labeled. Okay, so we have our horizontal axis laid out. Now we need to lay out our vertical axis. So again, I'm going to try to just sort of sketch this on here. You don't have to write this part down. I'm just usually putting it out there just sort of visually you can see what I'm thinking. So the horizontal axis and its scale is set by considering my equilibrium axis. So my equilibrium axis in this question is down here at minus 2. Now, my A value is going to tell me how high above that I have to go. So I'm going to add A to that. Now my A value is 3. So 3 units above negative 2. So if you can imagine, here we have negative 2, negative 1, 0, and positive 1. So that would be 1, 2, 3 units above that would actually just be positive 1. So negative 2 plus 3 gives us a positive 1. That makes sense. And we would consider that we would subtract A to find out what the lowest point is going to be. So take our A value, which is 3. So what's 3 units lower than negative 2? Well, that would be negative 5. So that's the thinking. Hopefully that's starting you're starting to understand how we might do that, since I think that's probably one of the more challenging things that we're doing here. So I'll just leave that on there. It's not going to be in the way, just so you can sort of have it and copy it down in a cryptic way. It might help you. So we know that we need to get down to negative 5 here and up to plus 1. So again, I'm just going to totally eyeball this and see if I can get something close. So if we're going to call that, let's say negative 1, negative 2, negative 3, negative 4, negative 5. Again, it's a sketch, doesn't have to be perfect. Negative 5, negative 4, negative 3, negative 2, negative 1, and then roughly the point of the same height above that at 1 right there, and that of course is 0. So that's how I set my vertical scale. So now I'm going to dot in my equilibrium axis, which is usually the thing I do first after I've got the horizontal and vertical scales drawn on. So that's going to be at minus 2. So I'm going to dot that through, kind of using the x-axis to try to keep it moderately parallel to that with varying degrees of success. And then we label y equals negative 2. And now I'm going to put on those 3 dots that I know are going to show up on the equilibrium axis, which is my first point. And you'll notice I'm making these dots pretty substantial. There's no reason to make them small. My second point in the middle, in this case at 180, and the third one at 360. So we have our 3 points on the equilibrium axis. Now we have to figure out our highest and lowest points. So I know that's going to happen at 1 and -5. The question is, do I go up and then down, or do I go down and then up? Well, my a value is a positive value. It's +3. So that means that our sine function is going to go up first and then down. So at 90 degrees, we're going to reach our high point. And at 270 degrees, we're going to reach our low point. Just trying to eyeball that and get it as close as we can and thicken it up a little bit. All right, that's pretty close. So now that we have our 5 points, we're going to sketch them together. Again, I'm doing my best to keep it kind of curvy. And there we go. Oh, I missed that last dot. That's heartbreaking. Okay, let's pretend it hit it though. There we go. Let's get some arrows on that thing. There we go. And now we're going to label our points. So the labeling is at 0 degrees. We're at a height of -2. At 90 degrees, we are at a height of +1. At 180 degrees, we are at a height of -2. At 270 degrees, we are at a height of -5. And lastly, at 360 degrees, we are at a height of -2. So there are our 5 points labeled. We need to label our function. So I'm going to label that y equals 3 sine x minus 2. So there we go. That's looking awesome. Let's get the range on this thing now just to make sure we got it under control. So again, we know our high point, we know our low point. We figured those out in order to get our scale on there. So let's just fill it in. So the set of all y such that y is an element of real numbers where, so we have low value, y, high value, close the bracket. So we know that y will be less than or equal to 1, makes sense, and we know that -5 will be less than or equal to y. And that is our third example. So this one really introduced this idea that we have an equilibrium axis, but our highest and lowest points by an a value other than 1, they might just seem a little bit different or weird. But I showed you on the side here how to figure it out, so hopefully that little cryptic thing stays with you right there. And we have one more example, and this one's the big one. We got horizontal translations or phase shifts, vertical translations, we've got a reflection. This last one's going to be crazy, so it is also a horizontal translation to the left, which is going to kind of blow your mind a little bit. So make sure you have make sure you're ready for this last one. And then there's just going to be a little bit on the tail end here that we're going to tackle as well. So I will see you in the fourth and final part of this lesson when you're ready.